Hi everyone, so today's one of my favorite days of geometry. We're in the beginning in chapter 2, and we're going to be talking about drawing conclusions. And we're going to do this through something called a one-step proof, okay? And so this is what I mean by a one-step proof. This week in class, we've learned about a conditional statement in the form of if and then. Now, I've given you if-then statements, and we've decided if they were true or false. We flipped them around. But now we're actually going to have to be able to write our own if-then statement based on a diagram, and we're going to have to justify that, okay? All right, so let's look at this first one. It says given B is between P and Q, and I'm given a diagram. What could we say here? Well, in the first couple weeks of school, we learned that if we were told that B is between, we could not say it was directly in the middle, even if it appeared to be. But what we could surmise from this would be that PB, so segment PB, plus segment BQ equaled segment PQ. And the reason we were able to do that, so the definition, theorem, or postulate that justifies that statement is the segment addition postulate. And you may remember I would ask you what segment or what postulate justified what you wrote down on your paper. All right, let's look at another one. Here we're given an angle. We're given that angle ABC, and we're given that BD that kind of goes through it. We've got these two angles, 1 and 2. So similar to what we just did, this diagram only allows me to say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. And that would be the angle addition postulate. So adding the sum of the parts equals the whole. All right, they're going to get a little bit harder. Now I say to you, M is the midpoint. Well, I know that the first thing you're always going to do if you see that is going to mark your diagram with the given. So we're going to mark AM congruent to MB. So for every mark we made, we are allowed to make a statement. So we could say in this case that AM is congruent to MB. We also could say that AM equals MB. Now notice, here I used the segment symbols, so I used a congruent. Here I was talking about the lengths being equal, so I didn't have to use a symbol. Remember, if I don't use a symbol, I'm talking about the length. Either way, it's fine, and the reason would be the definition of a midpoint. Hopefully you're getting the hang of this. All right, here's an if. If MN is equal to MP, okay, well, I'm going to mark that. Well, this is kind of working backwards on that one. It's kind of looking at the converse. So it's basically saying then I'm allowed to say that N is the midpoint. So if MN equals NP, and you're given this diagram, then N is the midpoint of MP. And that, again, would be definition of a midpoint, just in the converse form. And remember, we talked about definitions. You can write them both ways, and they'd be true both ways. All right, little trickier. Here I was given if BD bisects angle ABC. So in Unit 1, we did this. And I said we got to mark our diagram with the given. So hopefully you remember you would mark your diagram with angle 1 congruent to angle 2. So those marks will then result in being my then statement, okay? So angle 1 is congruent to angle 2, and that would be the definition of an angle bisector. This should all feel familiar. These terms I'm using should not be new to you, okay? All right, now again, we've been talking about the converse. When I flip things around, they can still be true. So if I give you a diagram and I tell you that angle 1 is congruent to angle 2, well then you can say ray BD bisects angle ABC. That again would be because of the definition. The justification would be the definition of an angle bisector. Okay, now remember again, it's a definition, so both the statement and its converse will be true. And so you see how I'm just flipping them around and see if you recognize what you might be able to do with them. All right, this one's a little trickier. There's that notation we've only just talked about a little bit. That symbol means perpendicular, and perpendicular lines meet at right angles. So I'm going to put a right angle right here and right here, okay? So there's a couple things that we could say based on the perpendicular. We could say that angle ABC is a right angle, okay? And that would be because of the definition of perpendicular lines, because they meet at right angles. We could also say that angle 1 plus angle 2 equals 90 degrees. And that would be either, you could say, the angle addition postulate, and I guess if you really wanted to, although I don't love this one as much, this one you could also say the definition of complementary angles. But that one you'd really kind of have to state it was a 90-degree angle beforehand. So I'm a little wary on that one, but it would work. Okay, I'd accept it. All right, and then here's our last one. Angle 1, I'll give you this drawing, and that's all I give you, and I label this one angle 1 and angle 2. Now remember I said that lines that appear to be straight, you can't assume they're straight. So really the only thing I get out of this is that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And there's lots of answers you could give for the reason behind this. I could say the linear pair postulate. Remember, two adjacent angles that form a straight angle, postulate. You could say the angle addition postulate, so the AAP. And like a close third would be the definition of supplementary angles, although I'd want to stay away from that one, okay? All right, guys, so that's just a little bit about how you can draw conclusions from diagrams, and we're going to be using this information in class when we really, put the muscle behind proofs, okay? All right, have a great day.